Now I want to discuss a little bit about clock. The microcontroller is a digital circuit. A digital circuit works on clock. Mainly a digital circuit is a combination of lots of states, and with every clock tick states changes. So clock is a very important basic concept which we need to understand to do the bare metal programming, because to make a microcontroller work you need to activate the clock of that microcontroller. So we have a base clock. You need to enable the overall system clock. You need to configure the system clock. Then for each peripheral, whether you want to use the port, you want to use the ADC, you want to use the PWM, you need to enable the clock separately. The clock architecture of STM32F4 is a little bit complicated. I will just tell you the important things which you need to know. We have two kinds of clock. One is internal clock. So with the microcontroller, there is internal clock also, and one is external clock, the crystal oscillator in our microcontroller. So that is the external clock, HSE. So this is your external clock. If your application is very simple, it doesn't need very high frequency switching. So you can use the internal clock. Internal clocks are basically low frequency clocks. If your application involves a very high frequency job like PWM, ADC, motor control, in that case, you can use the external clock, which is usually high frequency. Here we have a module which is called PLL. What PLL does is it multiplies your frequency. So even if you have a low frequency oscillator, let's say if you have a 3-4 megahertz, you want the 6-7-8 megahertz frequency, then you can use the PLL, you can configure the PLL, so it will multiply your frequency. But yeah, again, this also have some limitation. After the PLL, you will have your system clock. So this is your basic system clock. From this clock only, all the clocks will be distributed to different peripherals. From the system clock, if you will see, it will go to the AHP, Advanced High Performance Bus. So in the microcontroller, everything is connected to a bus. All the peripherals, all the devices are connected to a bus. And the bus, to enable that particular device, you need to enable the clock of that bus. For example, if you want to see whatever the peripherals connected with the APV1, you can use this divider to configure the frequency for that peripheral. Whatever the devices are connected with AHB, so AHB will come here. All the devices which is connected with AHB, you can enable the AHB clock configuration. So that is the basic of STM32F407 clock configuration. We will see which are all the important clocks are there which we need to enable. So if you are wondering why to enable clock for every peripheral, it's better if with system clock only all should run. So the answer to this is, so hardware it is designed in such a way that it should reduce your power consumption. So until and unless you don't need a peripheral, you will not enable its clock, then it will not consume the power. Since currently we are only doing a simple blink program, we really don't need very high frequency clock. First, also we don't need the PLL. So mostly we will use the internal clock of the microcontroller. We will configure the internal clock of the microcontroller. Then we will enable the peripheral clock. This is just a block diagram of STM32F407. Here you can see the different peripherals are there and they are connected with some bus. So for example, if you will see, all our GPIOs are here and GPIOs are connected with this bus, and this bus is nothing but HB1, Advanced High Peripheral Bus 1. So if you want to enable the any GPIO port, you need to enable the clock of HB1.